Find the volume of the solid formed by revolving the region bounded by the curves y equals x squared, y equals 0, and y equals 8 around the line y equals 8. No! Leave your answer in terms of pi. So what we're doing is we're taking a parabola and we're spinning it around 8. And we're going to get this weird oval-looking shape, pill-looking thing when all is said and done. So we are going to use the disk method, but around others, right? So the equation for that, the normal disk method is going to be integral from a to b, pi f of x squared. But since we're spinning this around a different axis, we're going to do f of x, the original equation, minus g of x, and then square that. So very similar, but not completely the same. Okay, so we need our limits of integration before we can do anything. So our limits are going to be found by taking the original equation here, x squared, and setting that equal to 8 so I can find out where x squared and 8 intersect. Oh, no way. This is going to be terrible. Square root, plus or minus, x is going to equal positive or negative 2 root 2. Oh, I hate it. I hate it. But thankfully, over here, we're blocking it off at 0. Okay, so I take it back. So we're not getting like a full pill looking thing. We're getting half the pill. So think of it as your doctor's telling you to cut your pill in half. It's a half medication. It's how I handle my anti-anxiety meds. So we're going from 0 to 2 root 2 on this one. 0 to 2 root 2. So let's set it up. 0 to 2 root 2. Let's rip the pi out front. We have f of x, which was x squared, minus g of x, which is 8. We're squaring the whole thing dx. That becomes pi from 0 to 2 root 2. That is a perfect square trinomial, so that becomes x to the 4th minus 16x squared plus 64 dx. Now we're free to integrate. Pi still lives out front. The integral of x to the 4th is 1/5 x to the 5th. The integral of negative 16x squared is negative 16 over 3x cubed. That's going to be a pain in the butt. And the integral of regular 64 is 64x. Your limits are still 0 and that god-awful 2 root 2. But fortunately, that 0 is going to make life a lot easier than having to deal with the other 2 root 2 that I originally thought we had to deal with. Pi is still going to be out there. 1/5 of 2 root 2 to the 5th minus 16/3 2 root 2 to the 3rd plus 64 times 2 root 2. Close that off. Minus 0. Why? Well, you plug in 0, you get 0. Minus, you get 0. Plus, you get 0. And then multiply to pi, you get 0. All right. Here comes the fun part. You ready? Here comes the fun part. Pi is still out there. 1/5 is still out there. 2 to the 5th power is 32 times. Root 2 5 times is going to be 4 root 2. Okay? Root 2 times root 2 times root 2 times root 2 times root 2 is the square root of 2 twice, which is 2 times 2 times root 2, which is where I get 4 root 2. Minus 16/3, a similar process. Okay? 2 times 2 is 4. No, 2 times 2 times 2 is 8, right? Root 2 times root 2 times root 2 is 2 root 2. Plus 64 times 2 root 2. Fortunately, I don't have to lose sleep over that one. So this becomes pi 1/5 times 128 root 2. I don't know why I put that up there. Let me move that down. 128 root 2. What was that? Minus 16/3. 16 root 2. Plus 64 times 2 root 2. 128 root 2 over 5 minus 200 and yeah, 256 root 2 over 3 plus 128 root 2. Multiply u by 3 over 3, multiply u by 5 over 5, multiply u by 15 over 15. I'm just going to wave my hands around a little bit. Okay, wave my hands around a little bit and just tell you what the answer is. And you're just going to have to trust me on this one. Pi is going to live here. Maybe we'll sneak the pi in right there. But boy, is that awful. Let me write that out one more time. 1024 pi root 2 over 15. When I created this problem, I made a mistake. I didn't want that to be 8. I wanted it to be 4, but I stuck with it, and I hope you stick with me because I love you. Thanks for watching.